Bismillahirrahmanirrahim. Let's start the Mohrs Circles. Last time we started this section of the Mohrs Circle in which we discussed the theoretical part of this Mohrs Circle, how it is drawn, what is the general state of stress, and then we discussed two-plane stress or the planar stress or 2D stress, and uh, from there we did some basic calculations of a Mohs circle, right? So today we are going to discuss a little bit more in detail, and then we will end up with some examples. And in this week, definitely, inshallah, we'll try our level best to complete the course for this mechanical material uh, stuff, right? So, where were we last time? We start discussing Mohs circles, obviously. Right. So we were discussing Mohs circle and we calculated the two basic values. One was sigma average, that was sigma x plus sigma y divided by 2. And this information gives me the center of the circle. The second value that I did, that was r, and it was sigma x minus sigma y divided by 2 whole square plus tau xy whole square under root, right? And this defines the radius of the this defines the radius of the circle, right? And obviously this was the case of the sorry planar stress conditions. This is sigma x, this is sigma y, this is tau xy, and then you have this sort of situation, right? And again, this was sigma x, this was sigma y, right? So from here, what we did, we draw the Mohs circle, and Mohs circle was like this one on the basis of these values. For example, this was sigma, and this was tau, and this was symmetric about the sorry. And this circle was symmetric about the sigma axis, right? And this was the circle. This was the center. This center was previously it was A, and then we just defined it with the sigma average, and this was the R, which was given by us from this value, right? So what we did last time, we did that this is the sigma max value, and this is the sigma max, and this is your sigma minimum values, right? And when it is sigma max, tau equals to 0, and when sigma min, the second value of tau is equal to 0, right? This is what we have already discussed in detail as well, that whenever you have maximum sigmas, so irrespective that is sigma max or sigma min, so tau value will be 0. So there will be so no tau is existing on this line. So tau value is 0. So whenever you have tau value 0, or you have been given the principal normal stresses, these are called principal normal stresses. Sigma max and sigma mins are called principal stresses or principal normal stresses, what some you consider. And it will always, at this condition, tau will be equals to 0. This is what we have already discussed in detail in previous lecture as well, right? But when tau is maximum at this, for example, at this particular point, tau is maximum, right? At this tau max value, this is tau max value, this is tau max value, but it would have some value of sigma, It will not be 0, right? And tau max value will be equal to the radius. So tau max you will directly calculate if you know the radius. So tau value will be maximum over there, right? So fine. So like this one, if we so now we have discussed two things. One is the graphical method, and first and second method we discuss is the by equation. And these two methods are used to calculate sigma and tau values at any given angle, right? Till now, before the Mohr circle, till the chapter 6, we keep on calculating sigmas and the tau values in the planar direction, directly x and the y directions, right? In this specifically chapter, now we are cutting this section in this way or in this way at any particular angle, and we are saying that these are basically the x prime and the y primes, x prime and this is obviously not perpendicular to this one. It should be perpendicular, but this is not the perpendicular like this one. This is now perpendicular, so this is y prime. So x prime, y prime. So these are at angular orientation for the x and y plane, because initially this was x plane and this was y plane, right? So any other angle other than x and y plane, if you want to calculate, so you have two methods. One is called by equation, and these equations are 7.5, 7.6, and 7.7. You directly put the values of the theta over there. If theta is, for example, given to you 22.5 degrees, so you will put the 2 theta value because that is sine 2 theta, cos 2 theta values, right? So you will put those values into this one and you will directly calculate the sigmas and other values, right? Fine. Sorry. So by for equations, we will go for this stuff, and then we can go accordingly for the values like this one, right? So there is some problem with this. Fine. So and another method is the graphical method. This is sort of the graphical method or the Mohrs circle method by which we can calculate the similar type of the values like the principal normal stresses or tau max values or values at any other stuff and any other angle accordingly, right? So the circle could be in any format, right? For example, there may be many shapes of the circle. For example, like one circle could be like this one circle could be like this one, another circle could be like this one. This will all depend, okay, what are the values in this. All values are sigma positive, right? Sigma, it is all sigma versus tau, sigma versus tau, sigma versus tau. This all sigmas are positive, so it means it is a tensile. It is partially tensile, partially compressive, and this is all compressive, right? So this all depends what sort of the sigma x and sigma y values you have in your problems, right? On the basis of this, you draw the circle and then you accordingly go for it. But all these circles will be symmetric, will be symmetric about sigma axis, right? So, so principal normal stresses can be calculated, and and in this particular case, obviously, if you are going for this one, this is A, this is B, so A will always be maximum, B will always be minimum value for the sigmas, and tau xy on this point and at this point will be always maximum values will be there, right? So and we can calculate any other value, because these all values will be the combination of sigmas and tau, right? These are the coordinates which are the sigmas and the tau. So sigma max, if we go from sigma max, will be sigma average, which is the center, plus r. Sigma min will be sigma average minus r values, right? So in this particular case, you may be asked to asked to solve particular questions. For example, question one may be that find the stresses, that find the stresses at, say, theta equals to 15 degree or theta equals to minus 30 degrees, right? In this particular case, you will straightforwardly go for the, you will go for the equation 7.5, 7.6, and 7.7. You will put these values into those equations and you will solve it. Second question could be that find principal stresses. Find principal stresses or find maximum shear stress values, right? For these, you can directly go for, you need to find sigma max, sigma min, and tau max values, right? So you can directly go to the Mohrs circle, right? So Mohrs circle will solve you this problem, that how to find these principal normal stresses and the maximum shear stresses, right? So at any particular values, you will go for this stresses, so you will go for the angular one. And if you are asked to solve the principal stresses or the maximum stresses, then you will go for the drawing of all this Mohrs circle, and from Mohrs circle you will directly find the values of this sigma max and sigma min, or the tau value. Now, the third important question: determine the direction of the principal stresses, right? And or tau max values, right? So this is the third important question. Direction means you need to calculate what will be the theta to get your maximum normal stresses as well as shear stresses, right? How we will calculate? A reference is equation 7.6, right? And 7.6, if you go to the 7.6 equation, you will find that that at that particular condition, when you have principal normal stresses, tau x prime y prime was equal to 0, right? Because that equation defines tau x prime y prime was equals to somewhere around sines 2 theta and cos 2 theta and sigma x minus sigma y. That was sigma x minus sigma y over 2 sine 2 theta plus tau xy cos 2 theta, right? And this was equals to tau x prime y prime. This was equation 7.6, I think, right? And when you will put this condition, right, so you will end up with right? So you will end up with tan 2 theta, tan 2 theta, sorry. So when you will put this equals to 0, so tan 2 theta will be tau xy over 2 tau xy over sigma x minus sigma y, right? And likewise, this is the principal angle, tan 2 theta p. This is the principal angle, right? And when you go for this principal, sorry, right? So, and total angle, we know when we will switch this to the shear stress, right? To tan to theta s, we know that principal normal stress, if we go upward, right? If you look at this point, this is your sigma and this is your tau max value, sigma max value and tau max value, and the angle exists between them is 90 degree, right? So angle between them is, total angle between them is 90 degree, right? So 2 theta p plus 2 theta s equals to 90 degree, right? So you will calculate theta p from there, and then you will subtract accordingly to calculate the 2 theta s value, and we will see it in the so the theoretical part of this whole this stuff is discussed, and now we will calculate, now we will go for an example, and then we will do it, we will solve an example of it, and then we will go ahead accordingly in our next video, right? For now I am ending up to give you a break, and in the next lecture we will solve an example of this one, and then probably another video we will solve another problem. So we will solve 2 or 3 problems of Mohrs circle, so that you have an idea how to calculate principal normal stresses, maximum tau max values, theta p and theta s values likewise accordingly. Right. So here I end my chapter, like lecture, first part of the lecture of the Mohrs circle, and then we will of this week, and then I'll give next lecture we will solve a problem. Thank you.